So welcome back everyone. Let us start with the second lecture of our binary trees, right? So the first lecture was regarding the introduction and now we'll proceed ahead with the question. So the question. So the first question, as you can see here, is level order traversal, right? So you have been given a tree and you just have to traverse it level wise, right? So you can see at the first level the node present is just 10, so it's 10 there. Then the second level it's 20 and 30, so 20 and 30 is printed, and then for the last level 40 and 60, right? How we can proceed this question is that we have to maintain a queue first of all, right? And in a queue we need to push our root node, that is 10, and then we will process our code while our queue is not empty, right? As soon as it is empty, it means that our whole level traversal is done. So now we will pop out the current node which is present at our queue, and we will push its children, right? So when we push its children, the 20 and 30 would be pushed, right? Then we'll again pop out the node 20, and then we will push its their children, right? So there would be 30, and pushing the other children will be 40 and 60. Then again we will keep on doing this thing until our queue is not empty. So let us see how the dry run is running. Then the 30 will be popped out, and since it has no children, the queue at this moment it will just have 40 and 60. Then 40 will be popped out, again it has no children, so only 60 will remain there. And then at last 60 will be popped out, and now the queue is empty, right? So now this is empty, and now your while loop should stop here, right? And you can clearly see that this is exactly the way the level order is printed, that is 10, 20, 30, 40 and 60, right? So let us code this thing. So how you can do this is, since the return type is an array list integer, so you have made an array list, right? Instead of just printing, we will be adding it in the array list. We make a queue structure, and then the first root node, right? We initialize the node given, that's the root node, right? So we add it in our queue, and we process it while our queue is not empty, and we pop the current node of the queue, right? We peek the node which is that particular node, we popped it out, and then we added in our array list, because that's what was return type in our question, right? And then when we popped it, we just have to check that whether it has left children or right children or not. If it is have, then you just have to add it in the queue again, right? And you have to repeat this process again till this queue is not empty, as we have showed in the dry run, right? So that's the Java code here. Let us compile and run, and we will see for ourselves. And while it's compiling, let us discuss the time complexity and space complexity as well. So the space complexity, that is, you are using a queue, right? So that means the space complexity will be O of n, because, or you can, let's say that at a particular time, the maximum number of nodes it will be having is of a particular level, right? So you can say that the space complexity will be nothing but the width of tree, and the time complexity will be nothing but O of n, because we are visiting each and every node once, right? So that is it. Your expected and expected output matches. Let us hit the submit button and we'll see for ourselves. So great, it has been successfully submitted, right? So let me show you the C++ approach as well, that what and all should be changed. The only that the method of declaration will be changed. The queue in the Java is declared in another form, while in the C++, right? So let us see that code as well, and then we will proceed ahead. So that's the C++ code, the same thing we have done, right? Let us submit the code, and then we'll proceed ahead. So great, all the test cases have been passed, right? Now there is a similar question. The similar question is there of the binary tree traversal in the Leetcode as well, in the given name as 102, right? But in this thing, what we need to do is that return the level order of its nodes values, that is from left to right, level by level, right? So you need to make here the return type is 2D array, right? That's the only difference. So so in the first array you need to return the first level nodes, and then in the second array you need to return the second level nodes, and so on, right? So first of all, what we can do here is that we need to traverse level wise now, because we need to store that thing. So what the other optimization or other, let's say, edit can you do in the code, right? So instead of just popping it out each and every node and then pushing its children, so you can clearly see that when we push the root node, let us maintain a one more variable, that is size, right? And whenever we push the root node, we will initialize a size that is equals to nothing but the current size of the queue. So that is 1, right? So we will now initialize a for loop, right, which will run size times. So it's only 1, so it will run just 1 time and it will pop the current node, right? And whatever be the size, whenever this size loop is finished, then we will again initialize the size variable. And then what we will do, that we will store the current size now. But definitely we'll be getting 20 and 30, so size equals to 2, right? And then you will run for loop for 2 times, and you'll do the same process for 20 and 30 you did, and you store the children, right? Once it's done, then you're gonna have to do the same thing, store the size, and then run the size times. And you can clearly see that what size is playing a role here is that once a level is finished, right, you are storing the previous level size in the size variable, and then you are iterating for those number of times. So when a particular level is finished, right, when a particular level is finished, then definitely whatever the nodes that will be present in the queue would be the children of this particular level, right? I hope I'm clear. So that's the only optimization we need to do in the code, or that's the only edit we need to do in the code. So we have to make a 2D list, as we have made here, then a queue node, and then queue dot add the root value. And here we can see that before running the level order traversal, you just have to store the queue size, right? And then you have to make, for each and every level, you have to make a array list of integer type, and then you can just iterate your for loop c times and do the same thing, that poll the current node and add it in your current array list. And if the childrens are not null, add it in the queue. And then at the last, for each and the last of for each and every for loop, you have to add that level of array list into your this answer, the whole answer, that is al, right? So that is it, and you can see all the test cases passed using this code. Let us hit the submit button. Again, the time complexity will be O of n, since we are visiting each node once, and the space complexity will be the width of the tree, right? So, okay. Yes, as you can see, it has been accepted, right? Now let me show you the C++ code as well. So that's the C++ code as well here. Nothing you have to do in the 2D arrays, just the syntax changes and each and every logic remains the same. Let us hit the submit button and then we will see for ourselves. So great, the C++ solution has also been successfully submitted. So let us end this video on a good note, right? And that's the reason I've showed you the another variation of level of traversal from the Leetcode as well. There was just a minor difference, that is to print it line by line, right? So let us end this video and we'll meet again for the tomorrow's next lecture of reverse level of traversal, and then we'll proceed ahead. So till then, bye bye, keep learning, keep growing, and take care.